Okay, so I need to show this. So I need to get rid of the b's and I need some sort of quadratic expression. So u v is going to be a plus I times b minus root 2I, which will be a times b minus root 2ai plus bi minus root 2I squared, which will be ab plus root 2 plus, in relation to i's, b minus root 2a. And since I know that this is the real component, ab plus root 2 has to equal root 2 plus root 6. Therefore, AB has to equal root 6. That's one thing that I know. And that B minus root 2A has to equal root 2 minus root 6. Okay, I need to get to this. I need to do some substitutions. I know that AB equals root 6. So I'm going to multiply everything by A. By multiplying everything by A, you'll achieve two things. I will get an AB that I could then substitute the B out with the root 6 minus root 2A squared. It picks up an A squared term equals root 2A minus, maybe I'll combine all of that together, minus root 6a, since I do have an a in there. Now I've got root 6 minus root 2a squared equals root 2 minus root 6 on a. And looking at what I want, I'm going to divide everything by root 2. Root 2, root 2, root 2. That becomes root 3 minus a squared equals root 2 divided by root 2 is 1 minus root 3a. So 0 equals a squared plus 1 minus root 3a minus root 3. And that's exactly what we wanted to find. If I crisscross this a, root 3 and 1 with the negative on the root 3, that times that gives me a, that times that gives me minus root 3a, which will be 1 minus root 3a's, which is correct. So one of my answers is a equals root 3, the other one is a equals negative 1. So one of the answers is a equals root 3 and b equals root 2. Find another one. Well, a equals 1, negative 1, and b will equal, since a times b is root 6, negative root 6. So that's a and b.